Hello and welcome to the Sky News live Q&A about this asteroid that we've all been hearing about that's potentially heading towards Earth. Now, we've been getting your questions over the last day on Twitter and YouTube, across the Sky News web and app as well. And we're going to answer them today. We've got myself, I'm the Sky News science and technology reporter, Mickey Carroll. And this is our science and technology editor, Tom Clarke.
That's right.
And we're also joined, we're really lucky to be joined by two actual scientists who can answer your questions even better than we can. So we've got Professor Stephen Smartt from the University of Oxford. Now, he works with the team that actually identified the asteroid in the first place. And we've also got Terik Daly from Johns Hopkins University. Now, he worked on the mission that managed to slightly alter the orbit of a moonlet of an asteroid, so that can kind of show us what we can do when this sort of thing happens and heads for Earth. But first of all, Tom, can you just give us a brief overview of what on earth we're talking about?
Yes, I think for those of you who might have missed the terrifying and probably inaccurate headlines about the potential threat posed by the asteroid, or maybe not. We'll hopefully find out. Asteroid 2024 YR4 was first spotted back in December, just before Christmas. And it only really started to make headlines, I think I'm right in saying, in January, when it turned out it had based on its the trajectory calculated by the very few observations that astronomers had managed to get, about a 1% chance of hitting the Earth, being a collision course with the Earth in December of 2032. Since then, that probability has gone up a tiny bit, sort of every month. Most recently, we're now standing at about 3.1% chance of a collision course with Earth, according to the latest data released by NASA in the last 24 hours. So what does that mean? Is the chance of it hitting us going up? How worried should we be? What, if anything, can we do about it if we should? These are all the sorts of questions we want to explore. But I think whenever we're faced by these potentially existential questions, we need to put ourselves on a collision course with the facts. And that's why we've got some professional scientists joining us. And I just thought I'd start, perhaps, Stephen, with you, seeing as you're a member of the team, the Atlas team, and I think I'm right in saying that's the Asteroid Terrestrial Last Alert System, which are 4 telescopes, I think, which are dedicated to looking for these near-Earth objects. What do we know about it, and what does this increase to a 3% chance of hitting Earth, what does that actually mean, and what should we take away from that in terms of risk at the moment?
So we know it's on a 4-year orbit. And so it's just leaving the neighborhood of the Earth now. It'll go out towards between Mars and Jupiter and then come back in 2028. So as you correctly said, the orbit is reasonably well known, but not, and the area of its uncertainty when it comes back in 2032 puts it, there's a potential that it could collide with the Earth. So I would say my first statement, I think, would be don't worry. To most people, it's almost certainly not going to hit, but the probability is large enough that we need to pay close attention to it and refine the orbit. Your question about is the probability, as you've rightly pointed out, has gone up from about 1% to 3%. And then, that's the tabloids and various other commentators start to get worried about that. I would say don't worry at all about the probability going up. It's entirely expected. So if you think that when the asteroid comes back, there's a large area, cross-section with the Earth, which is shrinking because our refinement of the orbit is shrinking. The Earth is within it. So the probability is likely to go up as if the Earth stays within that very large circle, that cross section. So it's expected that the probability will go up a little bit. I think nothing much will change now until 2028 when we have a chance to see it again. I don't think that 3% will deviate significantly unless there's a particular type of observation, which we can come on to. So I would think that the probability going up is entirely expected. It's still very low, and I would say it's almost certainly not going to hit, but we need to pay close attention to make sure we know if that probability really does increase in the future.
And when you talk about the kind of things that you're studying in this brief window that we've got to study this asteroid, what are we looking for when we're studying it?
Just more observations of where it is in the sky at particular times. So it's now roughly 600 times fainter than it was when it was discovered by Atlas, just because it's moving away from the Earth. So we need the biggest telescopes on Earth to detect it. The small telescopes like Atlas just can't see it anymore at its current brightness, just because of its distance from the Earth and the Sun. So we need the largest telescopes on Earth. These are big 8-meter telescopes. Their optical mirrors are 8 meters across. They're really the only ones on Earth now that can detect it. And soon it will disappear from the sensitivity of those. So all it is measuring where it is in the sky and precise timing measurements of the image that's taken. And that's enough to add to the orbit to help the calculations. And it will come from, there's probably another few weeks of observations left. The James Webb Space Telescope will observe it probably in April, late March, April, when it enters the zone of visibility for that telescope. That will help. It'll give another point, but it will also estimate the size. I think that's the major contribution from the James Webb.
I'm just going to jump in here. So I think we've got a graphic that, for people who are trying to get their head around the sort of the orbit of this, graphics team prepared a fairly crude graphic showing the orbit in relation to the Earth and how the two cross over. Very important thing to stress here, this is not to scale. The size of the space rock you're seeing before you is significantly larger than this object is. How important, you were just saying, and Terik, feel free to jump in at this point, because size matters, doesn't it, when it comes to objects like this. Why is there's quite a bit of uncertainty about how big this thing is. Why is that? And what observations, what might we be able to make between now and I think around April, when it's too far away for any of the assets we've got to be able to see it? What might we be able to figure out by then?
So one of the key uncertainties we have in how big this asteroid is that the telescopes that have been looking so far are largely looking in visible light. And we're measuring the amount of light that's coming back from this object, which is a point in space. We can't actually resolve it. It's just a point source. And if you imagine if you're staring at a lump of coal in one hand and a piece of chalk in the other hand, the brightness that's coming back to your eye could be the same if you have a very small piece of chalk and a large piece of coal. So what the James Webb Space Telescope observations will do, as my colleague referred to, in that March-April timeframe, is directly measure the size of the object by looking at emission in the infrared. So if we look at the infrared, we're actually measuring heat coming off that object. And then we're not as sensitive to these uncertainties in the brightness of in the reflectivity of the object, I should say. And understanding how big this is, if it's, closer to a swimming pool size or smaller, if it's like a football field, an American football field in size, that has significant implications for what the consequences would be in the unlikely event that this object were to strike the Earth. And that's why it's so important to not only refine the orbit, as my colleague said, but also have this improved information about the object's size.
We had a question from an audience member, from Scott on X, and he wanted to know what the difference of the makeup of the asteroid would make. So if it's made of rock or iron, what would that make a difference in if it did hit Earth? Is that something like the James Webb Telescope might be able to find out before it leaves in April?
So telescopes actually on the ground have already characterized what we would call the reflectance spectrum of the object. So looking at how light is reflected across this different wavelengths, and that can tell you like a fingerprint what kinds of materials this asteroid is made of. And right now that's showing this is a rocky asteroid. James Webb will also get information that we can use to refine that composition. Now, if this is a rocky asteroid, which is what the current data indicate, it's more likely to break up in the atmosphere for these smaller sizes as opposed to hit the ground. If it were metallic, it would be more likely to punch through Earth's atmosphere and hit the ground. So right now our understanding is it's stony. The James Webb observations will confirm that. And then the people that model what might happen if the asteroid hits the Earth can move forward with those rocky cases as opposed to ones that include metal options.
So are we going to know by April time? What other observations might there be that could really nail down that trajectory? I think what we'd like to know, I'm sure you guys would like to know, so we in the media can stop writing scary headlines about it. How likely is it going to hit? Are we going to be able to constrain that by April? Or are we really looking at 2028, which, as I understand it, the next time around in its 4-year orbit is going to be close enough for us to see? And should that make us a little bit uncomfortable? Because by 2028, then we've only got 4 years left before it comes around again. If we find out then it is on a collision course with Earth, we have a bit less time to prepare.
Yeah, I think that's a key question. I don't think, from what I know in my conversations with people who do the orbit estimates, that we'll know an awful lot more by April, when it completely disappears from both James Webb and the largest telescopes visibly. I don't think we'll know an awful lot more by then with current observations. What may help, and what can help, is people are now looking back through archival images pre-December 2024 for detections of this object, which can really help tie down the orbit. So if those are found, if there are any confirmed cases of detection, it may be in images and people just didn't know it was there and they didn't recognize it. So people are scouring through images taken with telescopes before December last year. So that could help. That's one possibility that could help tie down the orbit. And what is the most likely scenario there is that the probability would go to zero. I think that's the most likely thing that could come out of finding something there. I don't think we'll get significantly improved numbers on the orbit from new observations. The one interesting thing that could happen, which has been suggested, is you can, although when it goes out of view, when it becomes too faint to observe, it's still there, of course, it's still there in the sky, and it can pass in front of the positions of known stars. And if it does, then it will occult stars or dim the stars. And then, of course, you know exactly where it is because it's passed in front of a star of known position, although you can't see the asteroid, effectively casts a shadow. So that's a possibility. And the people are doing calculations to see if that is possible and at exactly what time they should observe a particular star in the sky. So calculations would have to be done, and the orbit's still a little bit uncertain. So it's not clear if those occultations will happen. But those are the possibilities of refining it before 2028.
So the idea there is if you know its trajectory, you know where known stars are effectively fixed in space, you would then focus a telescope on that star and look for a tiny dimming in its brightness. Is that it? Because it's the comet's passing in front of it. And if that happened at the time you predicted, you could be pretty confident that dimming was caused by the asteroid passing in front of it and would give you a very accurate position in space and time, more accurate than some of the observations made using telescopes so far. Is that the general idea?
Well, it's as accurate as getting exact position in time of the asteroid itself.
Okay,
but it's not clear if that. Yeah, it's not clear if that will work out. I think the most likely is we won't find anything in the pre-discovery images. We may not get an occultation, and it will really have to wait until 2028. I think that's probably the most likely.
Fantastic. So I'm just looking at some of the questions. And if you have questions, that we should remind you, there is a QR code that you on your screen, so you should be able to scan that to submit some questions and keep them coming. Now, I suppose although you have clearly explained to us the probability of it hitting the Earth is small and is just as likely to get smaller, if not more likely to get smaller than it is to increase as we get more information, which is obviously reassuring to hear. I think it's reasonable to say, well, if we did find out in 2028 that in fact it is on a collision course with Earth, where do we have a reasonable idea now where it might be on course to hit? And Chloe here has messaged in saying, if it was to collide with Earth, where's the best place it could impact to avoid disaster? I'm assuming the answer to that is where there's the fewest people, but it does raise the question, if we are on a collision course with this thing, or if it is on a collision course with us, do we know where it could land, and if so, what the worst case scenario, best case scenarios could be?
I can jump in with that. So in terms of understanding the places that could be at risk if the asteroid's on a collision course, that can be determined from current information about the asteroid's orbit. So there was a notification that went out from a group called the International Asteroid Warning Network, and that has information about potential places that would be along this, what we call a risk corridor. Now, in terms of areas that would be kind of better to hit or worse to hit, if it's in the middle of the ocean, far away from land, that likely would be a better case in terms of damage to people. than if it were to hit over a major metropolitan area. So until we have information that will refine that asteroid's potential cross-sectional location to smaller than the size of the Earth, if it's on a collision course, at that point, we'll know more about where it might hit. But as my colleague said, right now, the uncertainties in that asteroid's orbit are large enough that most of the cases don't hit the Earth, right? 97% of the potential paths through space currently do not intersect the Earth.
I think it's also worth pointing out. So we've had a question from Jess on Instagram who said, if it were to hit, is it going to destroy Earth? And I think we know that it's most likely not to. And I think it's really important just to stress, it's kind of done it already, but no, it's not going to destroy Earth.
I think, let's just take this one head on. If we are looking at a head-on collision, how large is this object? And compared to what we know about previous asteroid impacts or the physics of these things, how much damage could it do at both ends of the range? Because I realise I was uncertain if indeed it was, in the unlikely event that it was on a collision course with us.
So right now, the estimates of the asteroid size are that it's between about 40 meters and 90 meters in size. The observations from James Webb will reduce that uncertainty. With this kind of size range, we're looking at something that would cause localized devastation if it were to impact over a metropolitan area. Now, to put in context, people think asteroids, they think, oh my gosh, the dinosaurs went extinct. That asteroid, we think, was about the size of Mount Everest. That was a gigantic asteroid, a completely different class of object than we're talking about in terms of size and energy than YR4. So YR4 would be more analogous to the Tunguska event, which was an impact, an airburst actually that occurred back in 1908 over Tunguska in Siberia. And that leveled trees around a large, 1,000 square kilometers or so area. I don't know if my colleague wants to add anything else about the Tunguska event or what other analogies might be.
Yeah, Stephen, jump in.
Yeah, I mean, I think that's right. The size is uncertain in that region, and it's most likely a Tunguska type asteroid. I think as Terik said, the interesting thing is the composition of what, if it did collide, then what would happen to it. The spectra look like these stony type asteroids, so maybe more like an airburst, and that's what happened with Tunguska. So it could end up, it's like a stony type asteroid, exactly like Tunguska, similar type of size, and so would cause an airburst. But that would still be quite devastating, right, Terry? That would still cause quite localized devastation, maybe over an area of 30 kilometers across or so, 50 kilometers. So if it did hit an inhabited area, if it did hit the Earth and it did collide with an inhabited area, it is quite devastating, and we would have to take action. I think personally, the most likely is evacuation is probably the best mitigation strategy for this type of event. I mean, this was what the Atlas survey was designed to do, to find any fast-moving small asteroids that might be on a collision course with the Earth, and you didn't have enough time to do anything else other than evacuate. Because as Terik said, these other big asteroids, which might be, pose a threat to humanity, are completely different to this type of, small 50 meter type of object. And we know most of the locations of all of these few kilometer size objects that might do serious global damage.
And in a way, in the Tunguska impact, I had a quick Google. I think it was 890 square kilometres of forest that were flattened. It's a big impact. If that was a city, that would be pretty catastrophic. But I think there's a bit of a lesson in probability there as well. It did land in the middle of the Siberian steppe. And obviously there were fewer people on the planet in 1908, but it tells us the vast majority of our planet is uninhabited. If it was on collision course again, so the probability of hitting the Earth is very low, but if it was going to hit us, the probability of it hitting an urban centre is low again. Is that fair to say? Yeah.
And then, in terms of kind of where it's landing, though, if we're fairly sure it's not going to hit a city because there's so few within the path. We've had a question about what happens if it lands in the ocean. So,
for those of you who've watched the 1998 classic Armageddon, or was it Deep Impact? They both came out in the same year. So
I thought I should today.
You should have done it in preparation. There's a great moment in that film, actually, which it's been something as a science journalist in a TV newsroom. you're never very much in demand. It's always the business team, the politics team, the economics team. And there's a scene in that film where the editor rushes in and screams, "Get me science!" And this guy sort of shuffles in. I assume he's the science correspondent for this news programme and is suddenly put upon. But as in all these situations, I just call an expert and find out what they have to say. So again, I'm looking to you guys. But in one of those films, I think one of these chunks of an asteroid lands in the ocean and causes a catastrophic tsunami wave. And I know, once again, we're getting ahead of ourselves because we're still trying to constrain the probability of it even hitting the Earth. But are there scenarios in which an asteroid impact near an urban area or close to populations could still have wider impacts?
Yes, if this were to impact, which is unlikely, and it were over a metropolitan area, which, to your earlier point, makes it even less likely, then yes, there could be problems. One of the things I take comfort in is that within the US and internationally, there are organizations that have actually practiced how to respond to this kind of a situation. So there are 2 collaborations through the United Nations. One is called the International Asteroid Warning Network, which is this collaboration of observers and modelers. The other is the Space Mission Planning Advisory Group, which is the collaboration of international space agencies. And both of these groups are actively working the problem. And in the US, for example, NASA has a variety of efforts related to planetary defense that have also been activated. So, my colleague mentioned earlier that 3% is not enough to lose sleep at night, but it's enough to pay close attention. And NASA, its International Space Agency partners, these organizations through the United Nations, they are paying attention and they have practiced what to do in situations like this in the past. So if there's questions about, what happens if it hits the ocean or what happens if it hits a city, NASA has a group that's dedicated to looking at that. And they've done those kinds of assessments for hypothetical scenarios in the past. And so they're equipped to do those kinds of assessments for this real scenario that we're looking at with YR4.
And then I think the kind of other thing that's also been prepared for that you worked on, Terik, is DART. Like, we've also prepared for the idea that there might be an asteroid heading for Earth and we have to knock it off course. And so scientists chucked a satellite at the small moonlet of an asteroid and managed to slightly change its orbit. So we know that that's possible. Is that something that you think will happen with this asteroid? And, is it feasible? Do we have time? All of that.
So speaking purely as an individual, my expectation is that discussions about potential space missions won't begin in earnest until the object is no longer observable by telescopes. And that's because as long as it's observable, there's always the possibility that new observations could drop that impact probability to 0. As my colleague said, there are uncertainties, in that orbit right now. But I think when we get to that April-May timeframe, we might see additional discussions about space missions if there still is a non-negligible impact probability. Now, in terms of what we could do to potentially prevent impact if needed, the Double Asteroid Redirection Test, or DART, was the first demonstration of technology to do that using a technique called kinetic impact. Now, the DART spacecraft slammed itself into an asteroid called Dimorphos that was 150 meters across. So it's actually larger than we think YR4 is. It's important when we're trying to deflect an asteroid that we do so early. If you think about tapping your brakes to avoid a car crash, if you start tapping your brakes very early, you can do that lightly and still avoid a car crash. Whereas if you wait until you're close to that collision, you have to tap your brakes a lot harder. So what we want to do is, if this object is on a collision course, we'd want to try to prevent its impact early, because that gives us more time for that change in the asteroid's orbit to build up. Now, it's an interesting situation because, to my colleague's point, telescopes won't be able to observe this again until the 2028 timeframe, after it goes out of view of telescopes. So there may be an interesting situation where there's a non-negligible probability of impact, although, again, the most likely thing is it's not going to hit the Earth. But we don't have the opportunity to get more information from telescopes. So at that point, looking at space mission options may be appropriate. And in fact, these international groups, the Space Mission Planning Advisory Group, which is this UN-endorsed collaboration of space agencies, they actually have recommended criteria for when to consider space missions in response to asteroid risks.
Okay.
that is a group that has already been looking. People can look on their website. It's smpag.net, and you can see the statement they have. And that group is planning to look again at the situation, later this year and come up with possible recommendations at that time.
So the probability is 2028. We quite quickly find out probability drops to zero. We can all breathe a sigh of relief and move on. However, if it suddenly escalates to it is actually going to hit the Earth, would there be time? That leaves us not too many years to get something built and off the ground to intercept an asteroid, and I'm assuming probably later than we'd like to. If we found ourselves seeing its orbit confirmed on a collision course with the Earth, would we have time by 2028 to do a redirect? How long was DART in the planning? I imagine quite a bit longer than 4 years.
Yeah, so DART did take longer. DART was also built during the pandemic. Right. So I think, there was a lot of social distancing. There were a lot of logistical challenges that were associated with that. The DART did have closer to a 5-year development timeline. To your point, time is short. Space missions do take a while to develop. I think there are approaches that could be used to accelerate those timelines. For example, there are programs called Simplex that NASA has done that are shorter development timelines. Actually, the European Space Agency launched a mission called HERA last fall that was developed on a much shorter timeline than a typical mission out of ESA. So if we were to wait to make decisions until space mission options in 2028, my personal opinion is that would be a challenging situation. I'm never going to say that people aren't clever enough to come up with some solution, but I think that'd be very challenging. If decisions were made after this apparition ends, if there's this lingering impact probability that's non-zero, that buys us more time. So it will be interesting to see what happens in that late spring, early summer timeframe as space agencies decide, what to do with whatever knowledge we have about the impact probability at that time.
And Stephen, you were making the point that given the size of this object, and it's unlikely to get any bigger, we're looking at a size window, that it's reasonable to imagine one of maybe the most cost-effective thing here would maybe to look for an evacuation. If it was going to hit the Earth, we'll get a much better idea. Would it be possible to study the orbit close enough to know with more accuracy where it was going to impact? If it did look like it was going to impact somewhere where there's population, you could move them out of the way. Is that a scenario, an evacuation approach?
Yeah, I mean, the DART mission was fantastic, very impressive, and I was in awe of seeing the collision and the dust cloud that blew up once the asteroid hit. But the question is, and should we do it for this? As Terik mentioned, these organizations are technically very capable, will make good recommendations on the basis of risk, but they don't control the funding. So a government would have to decide, we're going to give you the money to do it. And, almost the only two countries really, I think, who could afford to go it alone are the US and China. The European Space Agency could do it, but then it's a group of countries and you've got to get them all together and make the decision. So as well as the technical aspects we've been discussing here and the observations, the scientific observations we want to make to reduce the probability, estimate the size a bit better. Then there's the obvious political and societal question about what we do given the risk. If the risk is a few percent and it disappears in April, we don't have any more information, what do we do? Do you spend probably $500 million to $1 billion to define a mission, to build a mission? Or do you wait until to see what the probability is and then define your strategy then? And again, yes, we would hope that we would, if this was going to hit, and we don't think it is, but if it was going to hit in a problematic area or the risk area was such that it was over inhabited areas, I think that we'd most likely end up with a scenario where we did have a smaller region on the Earth, the smaller area on the Earth where we thought it was going to collide, and then I think evacuation is probably the best. Then it costs less, but then you have to trust the calculations that you're going to know the region well enough to have that evacuation strategy optimized.
Well,
and if I may just to add to that point, planetary defense here, we're talking about astronomers making observations, we're talking about space missions, but it really does intersect with disaster management and preparedness, with legal and policy, with political considerations. So one of the things I hope that we'll see, particularly in that April-May timeframe, is that this discussion about responses, if we're at a non-zero probability of Earth impact, begins to engage more fully with the disaster management community, with the risk communication community, with the legal and policy community. Because as astronomers, we can collaborate with colleagues in disaster management. I certainly do that here, and NASA does as well. And we need to bring in those experts if we're starting to talk about, evacuation or things like that. But the US, for example, has convened interagency groups to look at this problem that include things like NASA and FEMA, which is disaster management, and the Department of State, for example. So I think from the exercises that I've seen here in the US that have actually helped run, there will be a cross-government collaboration that brings together the experts from these different disciplines to do that cost benefit analysis and see what makes sense to do going forward. And that collaboration that goes beyond space agencies and astronomers does increase my confidence that there will be an effective response to whatever situation we find ourselves in, come the April-May timeframe.
And I suppose just one finally, because I think we're running out of time, but I was just thinking, even if, the chances are that this all diminishes to a zero chance of collision in, certainly by 2028. We all breathe a huge sigh of relief, except, of course, journalists like me who are very excited about the story that we might be able to tell. But the fact that this is happening, the fact we're talking about it, could that be of benefit, given one of these days, and we might be talking thousands of years, of course, an object this size or larger will collide with the Earth, and is it possibly one of the upsides of this? Gets us thinking about it, it gets us talking about it, and what we might do if such a thing occurs. A dry run.
I agree with that sentiment completely. Even if the impact probability goes to zero, which is the most likely thing by far to happen, we will have a lot of lessons learned across the world about how people responded to this situation. Again, not only from the astronomy perspective, but also how did the news media cover it? How did governments respond? It's one thing to try to capture that in a hypothetical situation, which again has happened multiple times. But when the rubber hits the road and it's a real situation, we're seeing some things that differ from maybe how people expected this would play out. And so capturing those lessons, I think, is critical for using this opportunity to improve our readiness going forward.
I think that leads us really nicely to the end. And I mean, the title of this is How Worried Should We Be About This Asteroid? So in a word, do either of you think that we should be worried?
I'll let my colleague go first.
Not about this one.
No?
So not about this one, but there are plenty of other of these small asteroids out there, and we do need to monitor them.
Okay, great. And what about you, Terik?
It's a risk to be monitored, but not a threat to be worried about at this point.
Oh, that's brilliant.
Amazing.
Well, thank you so much for joining us, both of you. And we've had a great time here. We've both had some questions answered that we wanted to know about. So that's great. But it's also been great to answer your questions from online. So thank you for joining us. If you joined halfway through and you want to catch up from the beginning, you can watch on demand, and that will be on YouTube and across our channels as well. So thank you, and continue following the story. This is going to be a developing story all the way up till April, and then potentially for the next 8 years. So carry on following on Sky News.
Absolutely. Thanks again.